We are on question number 17, which is the question that we have located. Remember, I said this question has nothing to do with the question paper. Your question paper finding question 8, 9, 10, and sometimes 11 for you to answer this geometry. Remember, geometry has too much marks. Actually, grade 11 work is about 85% of your final examination. So let's write this question 17 as we usually do. So it is question 17. First, let's draw the shape. This is a bit complicated shape, but I'll try to draw it as it is. It's a bigger and there's a smaller circle. So there are two of them which are intersecting at one point. So let's wrap that and try to do this. Okay, there is our intersection. And between them, there is a line, which is a straight line, meaning it's a tangent to both of them, but they will tell us on the information. Let's try to draw that straight line, goes up and down. And from there, there's a line that is coming from, there's another tangent there, which is moving there and intersect with this one. And from here, there's a line that is moving there to the circumference. And there's from the intersection to the tangent. And there's a line there, which is coming this way. It's a bit better. And we have a line which is moving from there to there, and another one that is moving from here, passing through the intersection to there. So this is plus practically what we are looking for in terms of the term. So let's label it and see if we did not leave anything out. This is P with 1, 2, and 3. This is T with 1 and 2. And we have R with 1 and 2. This is our Q. It is labeled 40 degrees. And this is line which is having a B, and that's N. And we have A, which have 1, 2, 3, 4, 5, and 6. So it means we have drawn it properly because that's what we need to say. So like, as usual, we must go back to our information, meaning we go to the content given. In other words, you have to go back to the information like instruction before you can answer the questions. They said in the diagram below, two circles have a common tangent, TAB. So this is our tangent. And they said PT is a tangent to a small circle, and PAQ, and NAR are the straight line, meaning that we have two straight lines that are cutting each other, so we have vertical opposite angles in between. That's what it means. And we have been given that Q is actually equals to 40 degrees. Now, the first question says, determine with reason 3 other angles that are equals to 40. So you have to try and pick up what is it that you can find being equals to 40. Let's take our colors. So we have this as 40. Remember, this is a tangent. And if this is a tangent, it means that the angle that is between a chord and the tangent, which is this, is going to be equal to the angle that is subtended by it. So the first question, which is question point 17.2.1, because this is from 17.2, we're going to say that also A2 is equals to 40 degrees, and the reason is the tangent chord theorem. Okay, that's our first information. What else can we say is that the angle Q is also equals to angle A2. That is because of the tangent and the chord theorem. Also, the angle 2 will be equals to angle A5. That is the vertical opposite angles. And this is a tangent, remember, to the small circle. So it means that A5 will also be equals to P2. That is the tan chord theorem to the other side. So that's what you're going to write down. And then they give you 6 marks. How simple that can be. So A2 is equals to 40 tan chord. And we said A5 is also equals to 40 vertical opposite angles. And also P2 in the small circle, it's going to be equals to 40 because The angle A5 is the one that is between the tangent and the chord. That is going to be equal to the P2. So this is another tangent and a chord theorem. Not to be confused is if you can label it properly, and then you get your 6 marks. Can you see how simple that can be? Nothing difficult. You see 6 marks, you get scared, and there's nothing you have done. You just have to remember your theorems. Look at a diagram that looks complicated, but it's not really. Try to uncomplicate it through the theorems, and then you are done. Okay. The last question says, if P1, so let's go to the diagram. If P1, this is what we are talking about, the whole of this angle. It's given to be equals to A4. Now, A4 is this angle there. So they are saying if this angle is equal to that angle there, what must we do? We have to prove that PTRN is a parallelogram. PTRN, it's a parallelogram. So we have to prove that this shape there is a parallelogram. Folks, what must we do? We must try to figure out her properties of parallelogram. And that's where we're going to get it right. Remember, if we have parallelogram, we have to have parallel lines. Opposite pairs are parallel and also opposite pairs are equal. That is a parallelogram. Okay. One other thing is that if we have a line that is drawn on those parallel lines, so if we can prove that these two are P, T, and Rn are parallel to each other, then it means that those two angles will be equal in a way. So they're saying if P1 is equals to A4, then prove that PTRN is a parallelogram. Already they have given us one part which can direct to say TP is parallel to Rn. Let's write the information down so we can be able to deal with the situation. And you'll see how simple can this be if you are writing it. Okay. This information would say P1 equals A4. It was given, right? But this directs us to say PT is now parallel to Rn. Why? If we draw a Z there, look at it. Can you see? If we draw a Z there, we can find that these two are alternating. Because of these alternating angles, then we have these two to be parallel. So let's write that as our reason. So we have alternating angles. We are given them. Okay, alternating angles are given to be equal. That is the first thing. So what we need to do now is that if we can prove that one other angle, it is actually equal to something else, or if we can prove that these sides are actually equal, or these sides are also equal, then we have proven the parallel lines, the other parallel lines, other pairs. Meaning if we can prove that TR is parallel to PN, then we are done. So let's see if we can do that. If I'm using TR as my parallel line, it means that somehow I need to figure out that my, let's move the T, going to R, we don't have a Z, we only have the F. Can you see that? We have the F there. It means that this angle there, which is R, it's going to be equal to that angle here. That is my corresponding angles from the given information. And also here, I will have my angles. Let's see which one and which one, because this is the line we're talking about. So it can be this. This is my line going there and going there. So this angle here is also equal to that angle here. They are alternating angles. So that's what we are looking for. So let's see if we can find that TR is parallel to PN, or alternatively, we know that PT is actually equals to TA. Why? Because they are the lines or the tangent drawn from the same point. They are equidistant. Okay, the line drawn from the same point, they are equidistant, which makes what is this? A3 be equals to P1. So A3 is equals to P1 as much as it is equals to P2, P4. So that is the information that we are talking about. If these two are equal, then that one will be equal to it. So let's see if we can look at some other information that can lead us to what we are looking for. This is a triangle, and that's our exterior angle of a triangle. It includes that one, so it's not, because we talk exterior, we must go far. Let's see, this angle is also equal to that one there, and let me see, this one is also equal to this one there. What are we left with? So all the angles there are equal. We are done with that part. But if this is the case, then we have these two also corresponding. Okay, what we are looking for is to find this angle there. Let's label it a little bit. And this angle there with a relationship to talk about these two. Or we need to find this angle here and this angle here to have a relationship so that we will have the corresponding angles, and that means these two will now be parallel to each other. So let's check. Looking at shape PTRA, we have realized that T is equals to R2 because PT is parallel to Rn from the given statement. Also, we have realized that this angle, let's see, this angle T, let me see if you can relate R2 with angle P, because that's what we need to get it right. If angle P is related to angle R2, so it means we have get to the solution. Let's see. Angle P is equals to angle A4 as well. So it means, yes, that angle there, which is P1, is equals to P3, is equals to A4. They are all going to the same direction. Also, this is going to be equals to this one, because this is given. Let me write the information so that it doesn't confuse you. Angle P3, it's also equals to angle A4. That is the tangent and the chord on the small circle. So the tangent, the chord, and the small circle, it leads us to say that one is equal to this one there. Okay, and if that's the case, if this angle is equal to that angle there, and it's also equal to angle A1, look at this one. If it's also equal to angle A1, it means now that our side TR will now be parallel to our side PN, because that's what we are looking for, right? Let's maybe write it somewhere there. Our aim is to find PN be parallel to TR by finding that angle T is equals to angle P3. And that will be the corresponding angles due to the fact that the two are parallel. So that's where we are going. So we say P3 is equals to A4. Now we said A4 is also equals to A1. Now A1, it is also equals to A1, which is this one. Okay. Now A1 is equals to A4. Write it there, A1 and A4, and also A1 is equals to T1 plus T2, so the whole of T is also equals to A1. That is the exterior angle of this cyclic quadrilateral being equal to the opposite interior one. So that is the case. Let's write it that. We are saying A1 is equals to angle T. That is the exterior angle of a quadrilateral. Okay, if A1 is equals to angle T, and if T is equals to angle P4, that means that angle A1 is equals to P3. Okay, so let's put it here. A1 equals T exterior angle of a cyclic, of a quadrilateral, okay, of a quad, and therefore A1 is also equals to P3. Okay, if A1 equals to P3, this is all because of this A1 is equals to A4, which is vertical opposite angle to each other, and then it is equals to P3. So if A1 is equals to P3, this is my A1 we are talking about, and we have said that A1 is also equals to T. So it means that both of them are equals to A1. So it means that T is equals to P3, and that makes Pn be parallel to Rn. So that is what we are concluding. This is what we wanted to do, so it's not really there. This is what we want to do. So we're going to continue. As long as these two are equal, it makes T to be equals to P3. Remember, this is because they are both equals A1. Okay, and if this is the case, therefore, TR is now parallel to PN. And that is because of we have corresponding angles that are equal. Okay, now this is the case. It means now we have two pairs that are parallel. Remember, the one was PT parallel to Rn. Now we have TR parallel to PN. If we have two pairs that are parallel, it means that we have a parallelogram. So we are going to conclude by saying, therefore, PTRN is a parallelogram. Reason being, we have both pairs are parallel. So then you have answered that question. Usually it comes with 5 marks. It's a bit straining question, but if you practice it, you will get it right. And it's just all about knowing the basic of what it means of a parallelogram. So if you want to talk about a parallelogram or any other shape, you need to remember their properties and what makes them different from the others. Folks, this is the last question of the revision of geometry. I guess you're going to enjoy this, and you're going to make sure that you practice and practice and practice and make this geometry as simple as possible through your theorems and all those information that you have gained from your teachers and from all the information in internet and outside. And good luck with your matric. Thank you.